When deciding whether to include neutral conductors in raceway runs between an electrical panel and a lighting contactor, several factors come into play. Although the lighting contactor itself may not require neutrals, there are reasons to consider including them. Conversely, there are also arguments for omitting them. Let's examine both sides. Firstly, let's consider the reasons to include neutrals. One key aspect is future use. Even if the current lighting configuration doesn't need neutral conductors at the contactor, future lighting upgrades or modifications might. Including the neutrals now provides flexibility for later changes without requiring new wiring. Secondly, neutral conductors provide a ground return path. They help maintain the stability of the electrical system by offering a return route for electrical current. Including neutrals ensures a proper and safe ground return path. Thirdly, compliance with code is another factor. The National Electrical Code, or NEC, often mandates that branch circuits include both hot and neutral conductors. Running the neutrals in the same raceway as the hots ensures compliance with these requirements. The NEC is the standard for electrical installations. Following it ensures safety and proper operation of electrical systems. Fourthly, ease of troubleshooting is improved. Having both hot and neutral conductors in the raceway simplifies the process of diagnosing and resolving electrical issues. Technicians can easily access both conductors at the same location, making troubleshooting more efficient. Now, let's look at the reasons not to include neutrals. Costs and labor are primary concerns. Running additional conductors increases both the material cost and the labor required for the electrical installation. This is a practical consideration that can impact the project budget. Another factor is space constraints. The raceway might not have enough physical space to accommodate all the conductors needed for the lighting circuit, including the neutrals. Overfilling a raceway can lead to overheating and potential safety hazards. Finally, limited need is a valid point. If the lighting contactor definitively does not require neutral conductors, including them can add unnecessary bulk and complexity to the electrical system. This can make the installation less streamlined and more difficult to manage. In summary, the decision hinges on the specific circumstances. It's generally recommended to include neutrals for future use, ensuring a proper ground return path, maintaining code compliance, and simplifying troubleshooting. However, if space or cost are major concerns, omitting the neutrals might be a viable option. In that case, you must carefully weigh the potential benefits against the potential drawbacks. A thorough assessment of the existing electrical system, future lighting plans, and budget constraints will help determine the most appropriate course of action. Always consult with a qualified electrician to ensure the installation meets all safety and code requirements. Now let's further explain the reasoning. Considering the NEC, the most relevant articles would be those pertaining to wiring methods, grounding, and circuit requirements. Specifically, NEC Article 300 covers wiring methods and general requirements for wiring, including conductor fill and raceways, which is relevant to space constraints. Article 250 addresses grounding and bonding, which ties into the importance of a reliable ground return path. Article 210 outlines branch circuit requirements, including the necessity of a neutral conductor in many circuits. When assessing future needs, think about potential changes in lighting technology. For instance, if the current lighting use is a simple on or off control, future upgrades might involve dimming systems or smart lighting controls, which often require a neutral connection. These changes would be far easier to implement if the neutral conductor is already in place. The ground return path is crucial for safety. In the event of a fault, the neutral conductor provides a low impedance path for fault current to return to the source, allowing the overcurrent protective device, such as the circuit breaker, to trip and clear the fault. Without a reliable ground return path, fault currents might find alternate paths, potentially energizing conductive surfaces and creating a shock hazard. Troubleshooting is greatly simplified with a complete circuit. If there are voltage drops or unexplained circuit behavior, having the neutral readily available allows for accurate voltage and continuity testing. This can save significant time in diagnosing and correcting electrical problems. When space constraints are a concern, carefully calculate the conductor fill in the raceway using NEC Chapter 9 tables. These tables provide guidelines on the maximum number of conductors allowed in a given size of raceway. Exceeding these limits can lead to overheating and insulation damage. If cost is a major factor, explore alternative wiring methods that might reduce the overall expense without compromising safety or functionality. For example, using a smaller raceway size if the neutral conductors are omitted could save on material costs. However, always ensure that the chosen method complies with the NEC and any local codes. The decision to include or exclude neutral should be documented as part of the project's electrical design. This documentation should outline the reasoning behind the choice and any potential future implications. This record can be valuable for future maintenance or modifications to the electrical system. Another important consideration is voltage drop. While the neutral conductor doesn't carry current under normal balanced load conditions, it does carry current in imbalanced three-phase systems or single-phase systems. Long runs of conductors can experience voltage drop, which can affect the performance of the lighting fixtures. Including the neutral can help mitigate voltage drop by providing a more complete circuit. Consider also the type of lighting being used. LED lighting, for example, is becoming increasingly common. Some LED fixtures require a neutral connection for their internal power supplies or control circuitry. Even if the current LED fixtures don't require a neutral, future LED models might. Therefore, including the neutral provides a degree of future-proofing. When evaluating the potential drawbacks of including neutrals, such as increased cost and space requirements, consider the long-term benefits. The initial investment in including the neutrals might be offset by the reduced cost and effort of future upgrades or troubleshooting. A life cycle cost analysis can help quantify these long-term benefits. When designing the raceway system, ensure that it is properly supported and protected from physical damage. The NEC provides guidelines on the installation and support of raceways. Following these guidelines ensures the long-term reliability and safety of the electrical system. Consider the environment in which the electrical system is installed. In damp or corrosive environments, use appropriate corrosion-resistant materials for the raceways and conductors. This will help prevent premature failure of the electrical system. When working with electrical systems, always follow safe work practices. To energize the circuit before working on it, use appropriate personal protective equipment, and follow lockout-tagout procedures to prevent accidental energization. Furthermore, if the lighting system involves any control devices, such as occupancy sensors or dimmers, consider the impact on the neutral conductor. Some control devices can generate harmonic currents, which can overload the neutral conductor. In these cases, it might be necessary to upsize the neutral conductor to handle the increased current. If there are multiple lighting circuits in the same raceway, consider the potential for neutral current sharing. In some situations, neutral currents from different circuits can combine, potentially overloading the neutral conductor. The NEC provides guidelines on neutral conductor sizing to address this issue. When in doubt, consult with a qualified electrical engineer to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. An engineer can perform a detailed analysis of the system requirements and provide recommendations on the best approach. The engineer would also be able to calculate all of the load requirements and ensure there is adequate capacity for future growth of the system. They would also ensure that the conductor sizes are correct for ampacity, voltage drop, and proper short-circuit protection. All of these factors are important to having a safe and reliable electrical system. Remember that electrical codes and standards are constantly evolving. Stay up to date on the latest requirements to ensure that your electrical installations are safe and compliant. Continuing education courses and industry publications can help you stay informed. A well-designed and installed electrical system is a critical component of any building. By carefully considering all of the factors involved, you can ensure that your lighting system is safe, reliable, and efficient. These considerations include the initial installation, future needs, maintenance, and safety. An electrical system should be designed to last for many years with minimal maintenance. By using high-quality materials and following proper installation practices, you can ensure that your electrical system will provide reliable service for years to come. Make sure to always follow the relevant electrical codes and standards such as the NEC or any other local code adoption and amendments. If you are unsure about any aspect of electrical work, consult with a qualified electrician or electrical engineer. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. When making changes to an electrical system, it is important to document those changes. This documentation should include a description of the changes, the date the changes were made, and the name of the person who made the changes. This documentation will be helpful for future maintenance and troubleshooting. The electrical design should take into consideration the energy efficiency of the lighting system. Consider using energy-efficient lighting fixtures and control systems to reduce energy consumption and lower operating costs. This can also help to reduce the carbon footprint of the building. Make sure to properly label all electrical panels and circuits. This will make it easier to identify circuits and troubleshoot problems in the future. Use a permanent labeling system that is resistant to fading and damage. The electrical system should be inspected regularly to ensure that it is in good working order. These inspections should be performed by a qualified electrician. Any problems that are found should be corrected promptly. Furthermore, the electrical system should be protected from overloads and short circuits. Use properly sized circuit breakers and fuses to protect the wiring and equipment. This will help prevent fires and other electrical hazards.